So we understood Maxwell combined all the four equations and he told electric magnetic fields are present together and they generate each other. Okay, electric field oscillating, electric field produces oscillating magnetic field produces oscillating electric field. Okay, so this idea we had. Everyone listen. So Faraday's law is basically what? What is signifying here? Now change in magnetic flux produces electric field, and modified Ampere's law or Ampere Maxwell law. What it says? Now change in electric field produces magnetic field. Are you getting? Here in this case, your change in magnetic flux produces electric field. Here change in electric field produces magnetic field. So they are generating each other. Electric field generating magnetic field here, and in this case equation 3, magnetic field is generating electric field. Like that you can understand. Yes or no? So now we come to electromagnetic waves. So I have you got the idea what about these equations, and also remember Gauss law significance, Gauss law of magnetism. Gauss law of magnetism implies that what basically monopole, magnetic monopole does not exist. This implies, okay, monopole does not exist. Monopole, magnetic monopole does not exist. Does not exist. Okay, so this idea you keep in mind. Clear? So this idea you already have. These four equations give. Sometimes it will ask her to write all the equations, and a little significance if you ask also you can write. Okay, significance also you can write. Now come to the next concept. Right, source of electromagnetic wave. So what is the source of electromagnetic wave? That one will try to understand. Which is bigger? 1 coulomb. See, 1 coulomb is 3 into 10 to the power 9 start coulomb, right? Yes or no? So definitely 1 coulomb will be greater than start coulomb. But again, what you have? You asked here doubt. Try to understand. 10 to the power minus 1 amp coulomb. Yes or no? So here 1 coulomb is 10 to the power minus 1 amp coulomb. Try to understand. 1 coulomb what coming? 10 to the power minus 1 amp coulomb. That means I can write 1 coulomb is 1 by 10 amp coulomb. Then I can write 10 coulomb equal to 1 amp coulomb. That means amp coulomb will be greater than coulomb. Yes or no? Remember, coulomb is greater than start coulomb. Coulomb is greater than start coulomb, and amp coulomb is greater than coulomb. Yes or no? Remember that. So doubt got clear about coulomb and amp coulomb start coulomb. Okay. Now next listen. Source of electromagnetic waves. An accelerating charge or oscillating charge basically produces electromagnetic wave. Okay, so right, what is the source of electromagnetic wave? An accelerating charge or oscillating charge. Okay, so if a charge is moving with variable velocity or its acceleration is there, some acceleration is there, if a charge is moving with, okay, some acceleration, or basically its velocity is not equal to constant, its velocity is not constant, velocity is varying, changing velocity. Okay, then this charge what produces? This charge produces EM wave. What produces? EM wave. Both electric field, magnetic field, and it radiates energy. Okay, this charge produces electric field, magnetic field, and radiates energy. Yes or no? So whenever a charge is accelerating charge or oscillating charge, oscillating is like this, oscillating charge. So one like this one, oscillating charge. You know oscillation, you know, one charge Q is here. Now this is oscillating here. Okay, oscillation happen. Okay, or oscillations like this happening. Whatever oscillation you take. Okay. So like this also oscillation is happening. So one oscillating charge or accelerating charge What basically produces magnetic, electromagnetic wave. Okay, produces electric field, magnetic field, and also energy. Okay, so source you write everyone. A charged particle with constant velocity, can it produce electromagnetic wave? No. A charged particle at rest, can you produce electromagnetic wave? No. Only which charge? Accelerating charge. In bracket also you can write this one, acceleration. Some acceleration is there. Okay, you can write here also. This is velocity. This is acceleration. Acceleration should not be equal to 0. Acceleration should not be equal to 0, and velocity should not be constant, or here velocity is not equal to 0 also. Velocity is not equal to 0. Okay. So accelerating charge. Accelerating charge produces, V means velocity, V means velocity, A means acceleration. So an accelerating charge produces electromagnetic wave, or oscillating charge produces electromagnetic wave. Clear or not? Okay. Or basically produces, you can write also, it produces electric field, magnetic field, and okay, radiates energy. Okay. And energy also it produces, and radiates energy also. Okay, this one already we have discussed and we have done during electrostatics. So write everyone, source of electromagnetic wave. After that, understand one question: how electromagnetic waves are produced? That telling how it is produced. Question is there, 2 mark question. Okay, 2 mark you can write this. Now what is the answer? An accelerating charge or oscillating charge produces an oscillating electric field in space, which produces an oscillating magnetic field in turn, and that oscillating magnetic field acts like a source of oscillating electric field. Okay, then in this way, electric field and magnetic field regenerate each other. Electric field can create magnetic field can create electric field, and so on. Okay, so in this is the answer how electromagnetic waves are produced. So you have to remember, an oscillating or accelerating charge produces an oscillating electric field in space, which produces an oscillating magnetic field, which in turn is a source of oscillating electric field, and so on. It will go like this. So they both are regenerating each other. So what will happen? Now electromagnetic waves produced in this way. So you can write this answer. And also remember the frequency. The frequency of the electromagnetic wave naturally equals to the frequency of oscillation of charge. Okay, because due to oscillation of charge only, electromagnetic wave is producing. So oscillation charge frequency is equal to electromagnetic wave frequency. Similarly, energy associated with propagating wave comes at the expense of energy of the accelerated charge. Okay. So whatever energy of the electromagnetic wave, that is also coming from accelerated charge. So whatever this charge is accelerating and producing electromagnetic wave, so whatever its energy, charge energy, that same energy, okay, electromagnetic wave also has. So this is the idea how electromagnetic waves are produced and what is the source of electromagnetic wave. Please write down. Now listen, nature of electromagnetic waves. So what are the nature of electromagnetic waves? So electromagnetic waves are transverse in nature. What do you mean by transverse in nature? Now here the vibration or oscillation of the particles perpendicular to the direction of propagation. Perpendicular to what? The direction of propagation of wave. So this is the direction of propagation. Direction of propagation. Direction of propagation, and this is the vibration of electric field. You see, they both are perpendicular to each other. Yes or no? So this type of waves are called basically transverse wave. Okay. So direction of propagation like this, and medium particle is going up and down motion, doing up and down motion. Up and down motion, that is called transverse in nature. So electromagnetic waves are transverse in nature. So direction of propagation is from left to right, but particle vibration is up and down, perpendicular to the direction of propagation. Okay, that is called transverse wave. So electromagnetic wave is what? Basically transverse in nature. Now next, right? Next one, right? Complete this. Now the direction of electromagnetic wave is perpendicular to the electric field and magnetic field. This one already you have seen. Direction also will do the graph diagram will do. So direction of electromagnetic wave is always perpendicular to the electric field and magnetic field. Next, the electric and magnetic fields are oscillating perpendicular to each other in UM waves. That also we understood. If a direction of propagation is like this is a direction of propagation, D of P I am writing. If electric field is like this, electric field is vibrating like this, then magnetic field will vibrate like this. Okay, so they are perpendicular to each other already we know. One is electric field, one is magnetic field. Now the speed of electromagnetic wave in vacuum is 3 into 10 to the power 8 meter per second. Okay, which is basically denoted by, okay, this is denoted by what? C. It is denoted by speed of electromagnetic wave in vacuum by C. Okay, and you can write also C is nothing but 1 by root under mu naught epsilon naught. This one also write and keep in mind. C equal to speed of light, small c. The speed of electromagnetic wave is represented by what or denoted by C. C. So this one you can write as small c. You know, right? Small c. This one you keep. Now next write, no material medium is involved in the vibration of electric and magnetic field. Write down this page will be complete. And next point write, electromagnetic waves are self-sustaining oscillating electric and magnetic fields in space or vacuum. Okay, so these points 6 points you write, 6 points alone you write. Separately give point and write. Okay. Nature of electromagnetic waves. Transverse in nature. The direction of wave is perpendicular to the direction of electric field and magnetic field also. Okay. Speed of light or speed of wave basically in vacuum 3 into 10 to the power 8 meter per second. Okay. This everything you know. Please you write down all of you.